Welcome to the 7-day Practical AI Bootcamp, where we will be building AI apps, RAG, and agents. I am Vivin Arana, and this course is designed to help you learn practical AI by building real applications, not by just watching hours of theory. I and Arjun Ved will be the instructors for this particular course. Now, before enrolling, I recommend starting with this teaser project included in the course preview. Now, this single project gives you a clear overview of the technologies, concepts, teaching style, and development process used throughout the bootcamp. It shows you how we structure an AI application, connect to the large language model, write prompts, build the application logic, and create an interactive user interface. But we will not be explaining it line by line as we would in the next 7 days. And I want to be completely transparent. Now, if you complete this teaser project, understand everything we built, and feel confident that you can continue independently, then you may not need to enroll in the complete course. However, if you want more of a structured step by step guidance through more advanced AI application, we will be doing that in the next 7 days, and this bootcamp will take you much further. So, what will we be building? We'll be building an AI knowledge and research assistant. This teaser application includes four features. First is the AI chat, where we'll be building a conversational assistant with memory. Then we'll be doing a prompt lab, which is a reusable prompt engineering templates. Then we'll get into PDF RAG assistant, where upload a PDF and ask some grounded questions. Next, we'll be doing a multi-agent research team, where we'll have a planner, researcher, writer, and reviewer agents. Now the application runs locally with Python, Streamlit, Olama, MyPubDF, and ChromaDB. So let's get started. Let me share my screen. So there you go. So we have the application architecture available here. Now the application follows this particular flow here where the user connects using the Streamlit interface, and the user has available to him or her the AI chat, prompt lab, PDF RAG, multi-agent research team, which calls the LLM service through Olama. So I'll let you know what all you need to install or should have already installed. The RAG feature adds several additional steps. So PDF upload, then extract the text with PyMu split text into chunks, creating embeddings with Olama. We'll have store vectors in ChromaDB, then we'll retrieve relevant chunks and send question plus chunks to the LLM and get a grounded answer from that. So in this case, like PyMu supports extracting page text with page.getText from the PDF. We have ChromaDB here that can store documents, embeddings, IDs, and metadata, and then return and kind of perform nearest neighbor queries against those embeddings. So let's go ahead and check what all we need to install. So I'm going to go not in detail, but let you know what we need. Inside here, I'm going to open a new terminal here and make sure that you have Python installed. So let me just show you. So you can go to python.org, go to downloads, and have Python installed. Now, this is the most easiest part. I hope you can go through this, follow this, and install. So this is a prerequisite. So I'm not going to go into detail. There's like millions of videos online available. Next is Olama. Olama is very easy. It has the command right here, or you can download Olama directly from here and have it running for this particular application. Next, Visual Studio Code. Now we prefer using Visual Studio Code for our most of the description that we do, but it's up to you what you want to install for this particular project or through the entire course. I'm going to go ahead and open Visual Studio, and to check if I have Python available, it's either Python or Python 3 dash dash version. That will tell you. If it says Python not found, then you'll probably have to install it, or there was some problems installing Python for you. Next thing that I need is Olama. So I can go here, do the same Olama dash dash version, and it will tell me what version I have. Now, no matter what operating system you are, Mac, Windows, the commands are always the same. Also, you can install some libraries that we need. For this particular project, I'm going to get Olama 3.1, which I already have it installed. I'll show you. If you do Olama list, it shows what are the different models that are available. Now you can pick your own model from the models here, and you can go through them if whichever you like. Look at cloud, embedding, vision. Since we are doing embedding, we can use some of those. I am going to use Llama 3.1. That's what I'll use. It doesn't show me here, but I can just say Llama. And okay, I think since I have only this open, I'll remove this. There you go. Llama 3.1 is what I'm using. There's also Llama 3.2, Llama 3, bunch of different options available, but this is what I'm using. Up to you, which one do you want? If you see, I have this here. Now to get that, it's very easy. You can just say, oh, Llama, pull Llama 3.1 latest. So that's how you can get it. It also has the information in here. If you go to any of the model, it will tell you how to. So instead of run, you can just say pull. If you directly do run, it will run through it and also pull it, I mean, full first and then run the model and start like a chat GPT or copilot type of interface here, or question answering for you to run these locally. Again, the reason we are using Olama is so we can run our models locally. I hope you know about them. If not, we're going to explain more later in the course. So next one is we also need a nomic embed text, which is for embedding model. So I'm going to pull that Olama. You can also use some of the existing pre-existing libraries that are available with Python, but I am going to use nomic dash embed dash text, and this will pull that. Since I've already installed it, it's pretty quick, but if you see, it's only 274 MB or so. That's so it should not take much time to download it. Next thing is what we are going to do is we're going to create the project. So I've already created the project. If you saw here, I have created the project. It's called teaser. I am going to open this. So if you see here, I've created the teaser AI knowledge assistant. I've just created the folder. I've not done anything inside here, so it's pretty brand new. The thing that I want to do next is make sure that we create a virtual environment and add everything inside there. So I'm going to go ahead and clear this, and here I'm going to say Python 3. Now you don't know much about virtual environment. We're going to talk about it later in the course, but for now I'm just going to go ahead and create it. There you go. I'll name it VNV as a virtual environment, and it creates it. Now the code is similar to create virtual environment on both machines, but it's different on different machines depending on which one you're running. On Mac, it's VNV bin and activate. For Windows, it's a little different. It's just VNV dot VNV slash bin activate. Or if you're using Power Bash, it's a little bit different to activate it. But again, that's how you activate. And how do you know it's activated? By looking at this VNV, which means it is activated. So again, for this is the command for, as I said, for Mac. For PowerShell, it is .vnv slash script slash activate .ps1. For Windows, let's say command prompt you're using, it's again .vnv scripts activate .bat. So a little bit different for each one of them. So depending on your operating system, you can add those. Next thing, I want to make sure that my pip is upgraded. Oops, to clear first, and then I'm going to say Python 3 dash m pip install dash upgrade pip. This is our pip is our package manager. Make sure that everything is up to date and all the packages are in here, so you can pull all the different packages through that. Now let's go ahead and create the project structure. So I'm going to go ahead and create a bunch of different folders here and files here to make our project ready. So give me a second and I'll just create them and show you. So here we go. I've created all the folders and files for us directly here. Requirements.txt, which will have all the packages that we need. Config.py is for config. App is where app will run. Environment variables will be here. We have our venv folder because we've created an environment here, virtual environment. Next we have utils, which has our init file. This file can be empty. These files tell Python that the folder contains importable Python packages. That's why we used it. And we have PDF utils here where we'll be adding PDF utility functions. Services, again, init, and then LLM service. This is where the LLM service will be residing. RAG, we have init py, vector store. This is where will be vector database, and RAG code will go in. Prompts, we have init underscore py and templates.py. This will have our prompt templates. Data is empty right now. We'll be adding data as in when we do stuff. And then we have agents where I have the research team.py entire file over here. Now inside my requirement, now let's go ahead and minimize it. Make sure that your folder structure and file structure matches this. Again, this code is available in the resources, so you can directly get that if you want. And if we want to get more detailed explanation of these, we do that in every single project for rest of the 7 days. Now inside my requirements, I'm going to add some libraries that I need, and those are Streamlit, Olama, PyMuPDF, ChromaDB, python.environment, these ones. Now I'm save this, and here I'm going to install it by saying pip install -r requirements.txt. It will install all these packages on my in my virtual environment, so it stays separate from the other code. Streamlit applications are normal Python scripts launched with Streamlit run, but the rest of them you already know of, or if you don't know, we'll probably talk about them in the following days. So once this is complete, we will be configuring the application. So we already created .environment file. Inside here, I'm going to add some environment variables starting from Olama chat model. In this case, you can specify the model. You can have the Olama embedding model, specify the model over there, Chroma path, where the Chroma database will sit, and drag k equal to 4. Now this is a template that I've used. Again, you can set based on what you're using. In this particular case, I'm going to use Llama 3.1, so I'm going to change that from Gemma to Llama, but up to you. Whichever model you prefer, you can add it over here. Again, this Olama chat model controls the main LLM. This one controls the embedding model. Next, Chroma path tells, as I mentioned, ChromaDB where to store the data, and rag top k controls how many relevant chunks are retrieved. And we'll probably talk about it more in the rest of the days. So once this is done, let's go ahead and create and kind of update the config file. So I'm going to go here. I'm going to go ahead and clear this out and get some additional space for us to go through that config file. And inside this, I'm going to start with importing OS, then from import path from pathlib. Then I'm gonna import load dot environment from dot, and then again go ahead and load that environment file into the system. Once I've loaded that, I'm gonna say get environment and get the Olama chat model. If that is not specified, I'm gonna use the default as get Gemma 3.3:4b embedding model. I'll get that. Chroma path, I'll get that, and then rack top k, I will get that from the model. Again, one more thing I think we've left with Chroma path make directory parents true exist equal to this. Make sure that the folder is available. If not, it will create that storage folder for us. Again, I think I don't want to use this one because it's too big for us. It's 4 billion parameters, but I can use Llama 3.1. That is good enough. I already have downloaded. That's why I'm using that. Now, next step is to building the LLM service. Again, if you don't know what this is, we'll probably talk about more in our projects in day one and following. Next is the LLM service. So inside services, I have a file called as LLM service. So let's go through this. Here, I'm going to create the LLM service that I can access. We can start with importing any. Next, I'm going to import Olama. Then I'm going to go ahead and import our chat model, embedding model from config. Next step is to create some default system prompts. You are a practical AI assistant. Give accurate, clear, well-structured answers. State uncertainty when appropriate. Next, I'm going to create a read message content where it will get the response and read the message content for it. Again, I've added some comments here. Read text from an Olama response, and check here has attribute response is message. Return response.message.content. Return response message content in this particular case. Else, next step I'm going to do is generate the response, which takes in prompt, system prompt, and temperature of 0.2. Then I'm going to go ahead and inside here call the Olama chat model here. Pass the chat model that we use, as we know is Llama 3.1. Message as a role system prompt, which is what we have created above here, system default system prompt. Next, I'm going to say role user is the content of prompt, and then options temperature. Next, I'm going to return that read message content response dot strip. So I'm going to just get that. I'll also look for, if you remember, I've added a try, and I'm going to look for exceptions. The LLM request failed, confirm that Olama is running and that chat model is installed. So make sure that everything is available. If not, we'll get this exception. Next function is generating the chat response. In this particular case, it takes the history and the system prompts. It generates the response using the complete chat history. So here I'm going to pass the messages role as system and content as system prompt. I'll say message.extend with the history that we have. And then I'm going to go and try to call the model, chat model, call Olama and pass the messages, and I'll say temperature is zero point 0.3. I'll get back return the read message content with the response and strip it out. If there was a problem again, if the chat request failed, confirm that Olama is running and chat model is installed and pass the error that we actually faced in this particular case. Next, I'm going to say embed text. Now inside this, I need get text. So this is for embedding. What it does, creates embedding for a collection of strings. If not text, return. Try again. I'm going to pass call the embedding model, which is our nomic. I think whatever we had set inside here, nomic embed text is going to call that model. And let me go down, and then I'll say if has attribute response embeddings, I'm going to return those embeddings that I found inside that. Next, I'm going to say return response embedding. So it will return those embeddings back. Unless there's an exception, in which case I'm going to say embedding request failed. Please confirm that Olama is running and that it is and this particular model is installed. If you skip any of the previous steps, of course, this will not work. Next, let's check the Olama connection. So this checks whether the Olama server is reachable or not. I'm saying olama.list. So this will list me all the Olama models, which means Olama is running and reachable if it works. If not, it will give me an exception saying that Olama could not be reached. Start the Olama application or run Olama serve. If you see, we did not run that yet. So that's why it will probably give us that error. So this is our entire LLM service. Again, we'll be displaying or describing this line by line, each and everything in our days. So if you did not understand, I think it's a good thing to look at the next days and go through that. This is just a teaser project, so we'll be going through the code pretty quickly and implementing it. If you understood and you're with me, that's awesome. Let's go ahead and next create the prompt templates. So I'm going to go here inside prompts and templates, and in here first create the prompt template. So I have a beginner explanation here where system is you are a patient instructor who explains technical ideas to complete beginners. Instructions are explain the subject in beginner friendly language. Requirements are start with a one sentence definition, use a simple analogy, break the explanation into small sections, include only practical examples, end with three key takeaways. And then we have executive summary, some more detailed analysis. You can read through this, it's available in the resources if you want to do that. Action plan is important, where organize the work into phases, give each phase so I've given different instructions here. Blog article, you are an educational technology writer who, so depending on the use case, I have used different requirements or prompts here. These are basic prompt templates that I have. Now to build that prompt, I'm going to say build prompt template name, depending on what template is being called, subject and context. I'm going to call this function. So whoever calls this gets the template back from here. So I'm going to say template prompt templates based on a template name, get that from above. Next, I'm going to say context value context.strip. If context.strip, then no additional context was provided. So check for context. Next, I'm going to say prompt equal to subject or request, depending on the subject, the context value, and the task instructions. I'm going to put them here and then strip all the spaces. And then finally, I'm going to return this template system with the prompt to whoever called it. So I'm going to save this file. Make sure you save these files. And then next, let's jump into extracting and chunking the PDF text. So I hope everything is saved. Yes. So I'll go back to where is our PDF utils, right? PDF utils. In here, I'm going to go ahead and first go ahead and import typedict. Next, I'm going to import PyMu because this is needed for chunking the page or getting the pages. I'm going to create a class page text typedict of where we'll have page and the text. Page is the page numbers and text is a string of text that is included in the PDF file. Next, I'm going to say class text chunk typedict, and inside text chunk we'll have text, the page numbers, and the chunk number. Next, I'm going to create the extract pages from PDF. This is where we'll get the PDF bytes and we'll convert that into extract the text from there. So next, I'm going to say try document equal to PyMu PDF open. Try to open the PDF file, stream the bytes, and get the file type as PDF.
If there's an exception, I'm going to raise an exception, say the file could not be opened as PDF. Next, if I was, then I'm going to say pages list page text empty list. Try to get each and every page for go through each and every page and page number and enumerate to the document and get that, and start equal to 1, just because we now computer starts with 0 and we would like to start the page numbers from 1. That's why I'm saying start equal to 1. By default it will be 0. Then I'm going to say text equal to page dot get text, get the text from there, strip everything out from it, and then if the text is available, I'm going to keep on appending it to the pages with the page number and the text. Next, finally, I'm going to say document.close. Of course, always make sure that you close the documents or you'll be leaking memory. If not pages, I'm going to say raise value error and then finally return pages. Again, if you did not understand some of it, we'll be repeating it and explaining it in much detail in the future chapters. So next I'm going to chunk the pages. So this will chunk pages. So I need pages, chunk size of 900 by default, overlap of 150. Now in chunking, you have to make sure that you overlap so the context stays between different chunks of pages. So that's why we have given an overlap of 150 here. Now if chunk size is less than equal to, chunk size must be greater than 0. That's what I'm saying, I'm raising an error. If overlap is less than 0 and overlap is greater than chunk size, I'm saying overlap must be smaller than chunk size. So always do these checks before you run these applications. Next I'm going to say chunk. I'm going to create chunks of which is empty list, which is list of text chunk, and then global chunk number equal to 0. For page in pages, I'm going to say text equal to empty string and join the page text that we got with split in it. Next, I'm going to say start equal to 0 and go from run a while loop until the length of the text is less than, or the start is less than length of the text. And I'm going to add minimum, end equal to minimum, start plus chunk size, comma, length of text. Then I'm going to get the chunk text from there where I'll say text start colon end and strip from there. So if chunk text, chunk append, I'm going to append. If there's some chunk text available based on this, sometimes it might be empty. So I'm going to say chunk dot append text, page, and chunk. So this is how I create the entire object. Then I'm going to say global chunk number plus equal to 1, increment that global chunk number. So that means you're going to the next chunk and loop through it again and again. And if end equal to length of text, break out of it. Start equal to, set the start is equal to end minus overlap if it keeps on going, and then once it loops through all the different chunks through while loop and then for loop for each and pages, you are returning the chunks back right over here. So this is the entire application. Now why use again overlapping chunks? One of the important topic, and you should, if you have never heard of this, imagine one sentence begins near the end of one chunk and finishes in the next chunk. Now without overlap, important context could be split apart into two different chunks. The overlap kind of repeats a small amount of text between neighboring chunks, so that kind of helps to keep the context. So that's about it. I'm going to save this file and we'll talk more about it in the next 7 days, that we'll be covering this over and over again. Next, let's go ahead. I'm going to go ahead and close all of them, and I think there is something that is not saved. Let's see. Okay, I don't need the application architecture, so I can close this. Let's make sure all of them are saved, because sometimes what happens is we create them and we forget to save them. Our next step is to building the vector database layer. So inside RAG, I'm going to go into vector store, and in here I'll start with, so this is quite a lengthy process, so I'm going to make sure that I try to explain as much as possible in this, but again we'll be doing this later in more detail. So start with importing different files. Import hashlib. I'm going to import any, import ChromaDB, import chroma path, import embed text, and import text chunks. Next, I'm going to go ahead and create this client method, which kind of creates the persistent client of ChromaDB and returns the ChromaDB based on the path that is there. Next, make collection name. So this is where we'll be creating the collection. Collections are like, think of it as like tables inside a database in our case. And I'm going to say digest equal to hashlib SHA-256 file name and code, the file name with hex digit of up to 24 characters. Next, I'm going to say return that particular digest pack. Then I'm going to index the chunks. I'll take the collection name, chunks, source name, batch size, and this kind of adds the document chunks and embedding to ChromaDB. So I'm going to say if not chunks, there are no chunks to index. Client equal to underscore client, call the client function, try client.delete collection, name collection name. Exception, pass. Next, I'm going to say collection equal to client.create collection, pass the collection name. For start, in range 0, length of chunks, batch size, I'm going to go ahead and get the chunks, start, and give the batch size to it. And then documents equal to item for item in batch. So for each and every item inside the batch, I'm going to add inside the document the text. Next, I'm going to go ahead and create the embeddings. I'll say embedding text documents id is equal to f of collection name item chunk for item in batch. So for this, I'll collect all the IDs that are available. For metadata, I'm going to go inside each and every batch and take item and then get the source name, the page, the chunk inside there. Next, I'm going to add it to the collection. I'll add IDs, documents, embeddings, and metadata. So these are the items that will be added to our collection or our table inside the ChromaDB. Next, I'm going to return the collection.count. Then finally, I'm going to go ahead and do the retrieve chunks, which takes collection name, question, and top k, which are the top number of matching chunks that we got. So I'm going to say if not in a question dot strip return, because there is no question available. Then I'm going to go ahead and create the client again collection and then count equal to collection dot count. I'll check if there's values available. If count equal to 0, that means nothing found. Or else I'll say query embedding equal to embed text question of 0. The result will be collection dot query embeddings, get the query embeddings, and results get the top k comma count and include documents, metadata, and distance is in there. Distance is how further from the answer it is. Next, I'm going to say documents equal to results.get all the documents inside there. Next, I'm going to get the metadatas, then the distances, and then create an empty list of retrieved. And now I'm going to loop through it. So I'm going to say for documents, metadata, distance, in zip of these documents, metadata, and distances, I'm going to say retrieve.append. I'll get the text, the source, the page, the chunk, and the distance and add it to it. So one at a time. And then finally, I'll return the retrieved item. Next, I'm going to go ahead and format the retrieved context, right? That function here. This prepares the retrieved chunks for the LLM prompt that we'll be sending out. So I'm going to say sections equal to empty. And then for index item in enumerate retrieved start equal to 1. Again, you know why we do start equal to 1. I'll say sections dot append will pass the source, the index source, page item inside the item text and pass that out. And then return it back with two next line characters and join all the sections together and return this back. Now, inside this, something too important to know is persistent client stores the chroma data on disk rather than losing it immediately when the Python process ends. So Chroma's query operation performs similarity search and returns the closest records back to you. So I hope this was helpful. If you understood this, I think that's great. If you did not, we'll probably be going in more detail in our vector and drag tutorial later on during the week. So once this is done, let's go ahead and create our agents. So we have 4 agents that we're going to create inside our research team. So I'm going to here first, let's start with importing generate response service from services.llm service that we've created earlier. So first agent is our planner agent. So I'm going to start with the planner agent, which takes the topic as input. And here I'm going to write my prompt where the topic is topic. And I'll say create a focused research and writing plan and returns the main objective, 5 research questions, the report structure, and risk assumptions and limitations. Do not write the final report yet. So I'm asking it to create the planning document for it. It's going to return generate response. I'll pass the prompt in, and system prompt is you are a planner agent. Decompose topics into logical and useful plans. That's our actual system prompt that I passed along with the prompt that we gave. So that kind of creates our planner agent. Next, let's go ahead and create the researcher agent. So planner will plan things and give it to the researcher agent. So researcher agent, I pass the topic, I pass the plan and the source context. And then in here, I'm going to say if source context dot strip context equal to source context. Else, if it's not available, I'll say no external sources were supplied. Use general model knowledge, identify uncertainty, and do not claim to have browsed or verified current facts. That's what I'm saying. Next, I'm going to create the prompt, which is topic, plan, available source context, and develop organized research notes. What the researcher does is it prefer supplied source context. Do not invent quotations or statistics. Do not claim that web research was performed because we do not. Mark uncertain or time sensitive claims and separate findings, examples, risk, and open questions. That's what I'm doing here. Next, I'm going to say return, generate response, pass the prompt and the system prompt where you are a researcher agent, gather and organize reliable material for the writer agents with a temperature of zero point 0.2. Next, I'm going to go ahead and go to the writer agents. So now researcher agent researches and then gives it to the writer agent the research notes other than topic and plans. And the prompt here is the topic, plan, research notes, and I'll say write a professional report. This is the guy, as he's the writer, he's going to write, or he or she is going to write title, executive summary, key findings, practical examples, risk and limitations, recommendation, and conclusion. I'm saying do not add facts that are absent from the notes because LLMs tend to do that. Next, I'm going to again call the generate response, pass the prompt, system prompt, you are the writer agent, turn research notes into a clear and useful report with a temperature of zero point 0.3. Perfect. Now that that is done, I'm going to go back and create the reviewer agent. So after the writer is done, there will be a reviewer who will review what the writer wrote. In this particular case, I have topic and draft, which is what is passed here. So I'll say prompt, topic, and draft, and then review and revise the report where I'm saying improve the accuracy, internal consistency, organization, readability, practical usefulness, treatment of uncertainty, and removal of unsupported claims. And I'm saying return only the complete revised report right over here. So I'm going to strip that out and then again call the generate response, pass the prompt. You are the reviewer agent, produce the strongest and most responsible final version and give a temperature of zero point 0.1. Next, I'm going to say run the research team. This is the entire team, the finality of it, of kind of running everything together, which takes the topic and the source context. And I say plan equal to planner agent topic. So it's going to call that. Next, it's going to call the researcher topic with the topic, plan, and source. Then it's going to call the writer agent, which will create the draft, and then final report. I'll say reviewer agent, take the topic and draft and give me back the final report here. Next, I'm going to return everything back. I'm going to say return. This is the plan, research, draft, and final report. So that's my entire 4 agents built here, which go from planner, if you see here, from planner to researcher to writer to reviewer. This is like a sequential multi-agent workflow that we have created. And each agent, as you saw, has a specific role, a specific input, a specific task, and a specific output. I hope you understood. If you did not, again, we're going to talk about this and create a lot of these in the next 7 days. Our next step is now that we have created our agents, we have to create an interface. So I'm going to go inside my Streamlit app, which is app.py, and create code for that. So I've added the code here. The complete app.py is again included in the resources file. You can look through this. It creates kind of 4 different tabs and connects all the modules together. So you can look at start, you can look at the imports here where I've added all the different import files together in here. Then I've configured the page here where how the page looks like with page title, page icon, layout. I've given the title for each, and then I have created the Streamlit session state variables here. Streamlit session state can preserve like the chat messages and other values across application reruns, so that's why this is important. Then we have the sidebar here available. We have also created here the different tabs that we'll be using: AI chat, prompt lab, and we'll probably see this when we run the actual project. So, and then we have each and every tabs kind of resources in here. So check through this and then see if it makes sense. If not, we'll be probably explaining this step by step in the next few days. So save this file, and everything is available here, almost 400 lines of code. I'm going to save this file and I'm going to close this, and then first make sure that our Olama is running. So I am going to say Olama serve just to make sure. So it looks like it's already running. So if it's not, it will start it for you. So for me, it's running right now. Next, I'm going to go ahead and then run the Streamlit application. For that, I'm going to go ahead and say Python 3-m Streamlit run app.py. This is how I will run my Streamlit server. I run it, it will open my browser and show me my interface that I've created. This is what I was talking about, the app.py file that we wrote, the 4 tabs that we've created: AI chat, prompt lab, chat with PDF, and research team is all available here. and this will communicate with our Olama. I can check the Olama connection. You see Olama is running and reachable. Our chat model, our embedding model is displayed here. I can go ahead and clear the chat history. I can go here to AI chat, and here I can say your message. I will say in this particular case, I'm going to ask explain embeddings using a library analogy. That's what I'm going to say. It's going to go ahead and call Olama and use Llama 3.1 model and generate a response. That's the code that we had written for this AI chat part. So let's go ahead and see what it comes back with. And there you go. It said, explain, it gives me the question that I've given. And I said, embedding can be thought of a library cataloging system. And it gives me entire details about it. And then I can add my next message here. For the next thing, we can also check the prompt lab. I can say here as a beginner explanation, executive summary. So let's select executive summary. And here I can say subject will be how AI agents could improve, did I spell it wrong? Okay, improve customer support. And then optional context, I can give some optional context. I can say the audience is a group of non-technical technical. I think I can give a little bit of typos, it's fine. Business leaders, and I can say focus on benefits, risks, and first steps. And I'll say run report and run prompt, and this will run that prompt and give me some answers for this particular solution. And there you go, we have a generated output, executive summary, central message, key findings, risk and opportunities, and recommendation for next steps. I have everything available here. So next I can go ahead and chat with PDF. I can upload a PDF. In this particular case, I'll click upload. I have some PDFs here, so I'm going to use the AI governance policy as the PDF, and I'll say process and index this PDF. So what it'll do is it will create a nice database for us in ChromaDB, add the chunks to it, and activate. Now I can ask it the question like, what is AI governance? Ask the document. It's going to ask that document and give me an answer based on the question that I have asked to this particular PDF. So based on the provided, what is governance, AI governance refers, it'll tell me where the source is coming from, and it will also give me the source pages on which page it found those answers. So try with your own PDF and see how it goes. Finally, our entire research team. In here, we have our entire research team available. So I'm going to say, how can a company introduce AI agents responsibly? And I'll say use the active PDF as a source, which I have already available. Use that too for this. Now it's going to run the entire planner, researcher, writer, and reviewer, and give us a document based on, or write a document for us, which will be available for us to review. So the researcher agent again will retrieve the relevant passages from the PDF before creating its research notes, and this will kind of go through an entire thing. The important limitation here is the research team does not perform live internet search in this version. Now, without a PDF, which we have provided, it uses the local model's existing knowledge. So, Llama 3.1 knowledge. That knowledge may be incomplete or outdated. Therefore, make sure that the multi-agent research and writing workflow here might not work as expected, but will have some information for you. So, let's see what it gets back. And there you go. It took a little bit time, but we have the planner agent output of the entire output that planner agent created. We have the research agent output. We have the writer agent draft, and then finally the reviewer agent final report. This is the final report based on everything that I provided. And again, everything is done locally on your machine using the Llama 3.1 model locally. So I hope you were able to do this and get this working. Again, the code is available in the resources folder, and if you have any issues or questions, I think that's a good time to kind of enroll in this course and look through the 7 days. But if you understood everything that we did here, I guess this course is not for you, and you can explore some of the other courses that we have to offer. But I hope to see you again in day one, and I hope this was helpful.